The velocity of an object moving along a line is given by v of t is equal to 4t squared plus 3 feet per second on the interval t. Divide the interval 0 to 4 into 4 subintervals. On each interval, assume the object moves at a constant velocity equal to the value of v evaluated at the midpoint of the subinterval, and use these approximations to estimate the displacement of the object on 0, 4. So B says do the same thing except with 4 subintervals. So here's what we're using as our reference point for A, and then we double the amount of subintervals on B. Now recall that displacement, what we're looking for, is velocity times time. Okay, so each one of these little squares is an estimation of the displacement. Like this little rectangle, not square, is estimating the displacement from 0 to 1. Okay, and the displacement is velocity times time. So the velocity we're getting from evaluating this point right here, because this is a velocity graph. So we're asking what's the velocity right here? And once we find that velocity, we say, okay, we're going to say that that's the velocity on this entire interval, even though it really isn't, but it's an estimation. So since it's an estimation, we just take one velocity, we'll take it in the middle, and we'll say that the velocity is really just a flat line from 0 to 1, and then another flat line from 0 to 2, and from 0 to 3, and 0 to 4. Obviously, there's going to be some error here. You can see that the rectangles are going above and below, but given that they are both going above and below, it probably is going to be a decent representation of the displacement. And as we get more subintervals, you can see that it seems to be more closely following this line. There's less above and less below, and it still seems to be kind of evening out what's above and below. Okay, so let's start estimating this. Since we have the interval 0 to 4, and we have 4 intervals, to figure out how far each one of our intervals is, which we can just look and see that each one of our intervals is 1 unit long. But if we couldn't see that as readily, you can take the interval 4, remember we're going from 0 to 4, so 4 minus 0, divided by your number of subintervals that you have, which is 4. So obviously that is 1. So each subinterval there, each one of these is going to be 1 unit long, and you can see that from the graph. Okay, now our remaining job is to figure out what the height of these little dotted lines are. Okay, so we need to figure out, since we are using the midpoint, we need to figure out where this point is. Okay, so what's the halfway point between 0 and 1? What's the halfway point between 1 and 2? Or between 2 and 3? Or between 3 and 4 to the end? Because these are our 4 intervals. Okay, so this would be 0.5, 1.5, 2.5, and 3.5. You just do the same thing. We just take the average of those two. So add them up and divide by 2, add them up, divide by 2 to get the midpoint. Okay, so to figure out the actual dotted line, we have to plug that into the formula, or the function, which is 4t squared plus 3. Okay, we plug in 0.5 and we get this dotted line. We plug in 1.5, we get that dotted line. Okay, so to make that a little easier on ourselves, let's go to the calculator and type that in the graph, or in the y equals 4x squared plus 3 instead of 4t squared plus 3. Okay, and then there's a couple different ways we can go about finding these values with the calculator. Sometimes I like doing this way. I go to the main screen and I hit vars, y vars, enter, and enter on y1, and I open parentheses and put in the value that I want. Okay, so that's telling me that the thing that I typed in y1, which is our velocity function, at 0.5 gives you a value of 4. So v of 0.5 is equal to 4. Okay, you can do that again by hitting second enter. It just pops up what you just typed in. Change this to 1.5, close parentheses. So v of 1.5 is equal to 12. Second enter, change it to 2.5. V of 2.5 is equal to 28. And finally, for 3.5, V of 3.5 is equal to 52. Okay, so we need to find the area of each one of these rectangles. We have the height and we have the base length. So base times height gives us our area of each rectangle. So each one of these, like let's say this is a displacement estimate with 4 subintervals. Okay, and that's equal to, the first rectangle is 4 times 1. 4 times 1, the height was 4, and the base was 1, plus 12 times 1, same thing, plus 28 times 1, plus 52 times 1. Okay, and if you add all those up, you get 96. So the estimate of the displacement using 4 subintervals is 96 feet. Okay, now we're going to do this again, but we're going to double the number of subintervals. So we're going to do it with 8. Okay, so it says repeat for 8. So now we're looking at the right graph. Okay, so we're looking at this graph right here, and we're going to have 8 subintervals. Okay, so if we have 8 subintervals, we still need to figure out what our subinterval length is. Again, this is pretty easy. You can just look at it and say, okay, well, it looks like they're each 1/2 unit long. But the way to figure it out without looking at a graph would be to take the end point and the beginning point of your interval and divide by the number of subintervals, which we know is 8. So that's going to be 0.5. 1/2 or 0.5. So each one of our subintervals is 0.5. So we're going to go from 0 to 0.5. Then we're going to go from 0.5 to 1. And then from 1 to 1.5. And then 1.5 to 2. And then dot, 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 dot. And then the last one would be from 3.5 to 4. Okay, so those are our intervals. Now we need to find a midpoint of each one of those little intervals. Okay, so the midpoint from 0 to 0.5, what's in the middle of those two? Well, you can add them up and divide by 2. So you add these two up and divide by 2, you get 0.25. Okay, so our midpoints are going to be equal to 0.25. And then add these up. 1.5, you add these up and divide by 2 is 0.75. And then 2.5 divided by 2 is 1.25, and you can probably see the pattern here now. Okay, so the next one is going to be 1.75, and then 2.25, 2.75, 3.25, and 3.75. Okay, those will be our midpoints that we're going to use, just like we did last time, to find the height of these little rectangles here. Okay, so we use those numbers to plug into our function. I'm going to do it a different way than I did it last time, just to show you 2 different ways of getting this. So we still have it typed in the calculator. Okay, and we can hit window, or not window, second window, sorry, and go to ask. Okay, and then go to your table, and notice I've already got all these typed in. I typed them in ahead of time, but you type in 0.25 and hit enter. It allows you to type them in there, and you type them in and you get an answer. I've already got them all typed in here. Okay, and we know, so we have the values, so I can write down a couple of these. So V of 0.25 is equal to, what did the calculator say? 3.25. Okay, V of 1.25. Whoops, I skipped one. Cross that out. V of 0.75 is equal to 5.25. V of 1.25 is equal to 9.25. And then so on and so forth. We have the values in our calculator, so I don't need to well, actually I do need to write them all down. So let me go ahead and write them all down. So let's see, 1.75 is equal to 15.25. Okay, and you might see a pattern here. There is kind of a pattern here. Look, this one increases by 2. This one increases by 4. This one increases by 6. So the next one would increase by 8, according to the pattern. So 23.25, and that is correct. That's what the calculator says. The next one would increase by 10, so 33.25. And then by 12, so 45.25. And then by 14, so 59.25. Okay, so those are our values. And we're going to multiply to get the area estimate. We're going to add all these up, but each one of them has to be multiplied by the base, right? Because these are each rectangles. These are each these rectangles right here. So we've got their height. Like the first one, the height is what? 3.25, but it's got a base of how far? Well, the base is equal to the subinterval, and each one of these was equal to a half. Okay, so we're going to add these up, but multiply each one of them by half. And you can add them up and then multiply them by half at the end if you want, or you can do it each time. So let's go ahead and add these. My calculator here where you can see it. Okay, so 3.25 times 0.5 plus 5.25 times 0.5, and keep going. Let's see, where was I? 23.25 times 0.5. Okay, so you do all that, you multiply each one of those by 0.5 and add them all up. And you could also, like I said, you could just add them all up and multiply the 0.5 at the end. You'll still get the same answer. But either way, your displacement estimate with 8 subintervals is equal to 97 feet. So a little bit different than our other one, which was 96 feet. And more than likely, this one is going to be more accurate. And if we doubled the number of subintervals again to 16, or doubled them again to 32, you would get a more and more and more accurate picture of exactly what the displacement is on this.